It's all about the timing, folks. Hello. Welcome to page 3 of the Algebra 1 Unit 5 test review. I'm glad you could see me in this state. Homesick. But still making videos for you. So, let's get started, shall we? 3 apples and 5 bananas cost $3.46. Okay, well that sounds like an equation to me. 3 apples and 5 bananas cost $3.46. A, let's see, A will be apples. B will be the banana, etc. It's a B, not an H. No. Okay, 3 apples and 5 bananas, 3 apples and 5 bananas cost equals $3.46. The next one, 3 apples and how do you circle this? 3 apples and 8 bananas. 3 apples plus 8 bananas equals $4.96. There's our system. Oh, they want the actual solution. What's the cost of an apple? Okay, well, looky here. These two right there. Same coefficient, different signs. So let's just go through and change our signs. This is what we have now. I'm just going to change the signs like that, and then I'll combine. This zeroes out. No more A terms. 5 minus 8, that's minus 3. Good start. Minus 3B equals, let's see, 346 minus 496. I'm going to break out the old calculatory device on my phone. Looks just like the good old TI-83 Plus made back in the 1300s. Let's see, 3.46 minus 4.96 equals negative 1.5. So let's divide by 3, and that goes away. So B equals, well, 1.5 is 3 halves, so we divide by 3, that leaves 1/2. So B is 1/2, which is, well, we're talking in cents. So bananas are 50 cents. These are 50 cents. Let's find out how much an apple is. Let's take the banana price, plug it into one of our equations. Let's do that one. So 3 apples plus 5 bananas at 50 cents a piece equals $3.46. So let's multiply that out. That's 3A plus 5 times 0.5 is $2.50 equals $3.46. So let's subtract that 250 from both sides. Subtract, that goes away. We have 3 apples equals 3.46 minus 2.5 equals 0.96. So that's 3 apples, but we want the cost of 1 apple. So 1 apple is, let's see, was that 32 cents? Yeah, 32 cents. So apple banana equals 0.32 comma 0.50. So the cost of an apple is 32 centavos. There we go. Okay, let's see. The sum of 2 numbers is 20. Ooh, these are fun. The sum of 2 numbers is 20. Well, sum comes from adding things, right? And that's is 20. So when we have 2 numbers, so let's call them x and y is 20. So there's 1. X plus y equals 20. Then the greater number, which really we can call either one. Let's call it x. The x number is 7 less than. We're going to subtract 7 from the next bit. That's what that means. 2 times the smaller number. So 2 times y. Let's write it out there. I know that's messy, but let's go through it here from the beginning. The x number, x, equals 7 less than 2y. So 2y minus 7. That's 7 less than 2y. You get 2y first and you subtract 7. Okay, find the two numbers. Well, here's our system of equations. And looky here, x is already solved. So let's use substitution. Let's plug this in for x right here. So let's rewrite this as 2y minus 7 instead of x plus y equals 20. That's what we did right there. Okay, so 2y and y, that's 3y minus 7 equals 20. Just combined this y with that y right there. And now I'm going to add 7 to both sides. That zeroes out. It gives me 3y equals 27. Divide by 3, so y equals 9. Okay, so y is 9. So the solution xy equals something 9. Let's find out what x is. Well, x is right there. X is 2y minus 7, so x equals 2, but instead of y, putting 9 there. X equals 2, y minus 7. So that's x equals 18 minus 7. So x equals 11. Here we go. Okie dokie, what's next? What's next for us? A 150-foot cable is 50 is cut into 2 pieces, so x plus y. There's the first one. 150 equals, you know what, I'm going to write it this way. X plus y equals 150, just so it's in standard form for us. The first piece, let's call it x. So the x piece is equals 22 feet longer than, so that's a plus, longer than the second, the y piece. So x equals 22 plus y. How long is each piece of cable? Well, let's find out. This is set up to be substitution because x is already solved, but you know what? I'm going to do one with elimination. So I'm going to subtract y from both sides and rewrite this all like this. I'm going to just put this down here. X minus y equals 22. So I'm going to rewrite it all right here. X plus y equals 150. That's the first one. And then x minus y equals 22. Okay, so there we have our two equations. Let's get you back over here. Here's our two equations. Let's solve. See, look here. We have same coefficient, different signs. That's ready to go. So we can just zero that out. So 2x equals 172. So divide by 2, we have x equals, what's that? 86? Yeah. No. Yeah. 86. So x is 86. So we can plug x. That's 86. Plug that back into either one. Let's plug it up in the top one so we don't have any negatives to deal with. X is 86, so 86 plus y equals 150. Subtract that 86 on both sides. That goes away. Y equals 150 minus 86. Let's see. 150 minus 80 is 70. Minus another 6 is 64. So there's our two pieces. 64. Add them together. That's 150. Yep. All right. Anything else on that one? Oh, solution. X, Y equals 86, 64. There we go. Okay, last one. Let's get some. Ellie has 32 coins in her piggy bank that are all dimes and quarters. The value of all the coins is $5.75. Okay. Well, this is a little unlike the other ones, but we have two types of numbers that we can count. The first sentence has a number of coins. So that's going to be your first equation. 32 coins in the piggy bank, 32 coins, and they're all dimes and quarters. I'm going to rewrite that. So dimes and quarters equals 32. That's the number of coins. Then the bottom one, here we have the value of the coins. So the second one is the value of all the coins. So we're going to put the value with each of the variables here. So we got dimes and quarters. And dimes are worth 0.10 cents. And quarters are worth 0.25 cents. And the value is $5.75. So we need to find out how many quarters she has. So let's at least solve for Q. And this is set up in standard form, so I'm going to solve by elimination. And we're using decimals this time. Let's multiply the bottom. I have a Q on the top there in the blue equation and a 0.25 Q on the bottom. I'm going to regret this. But I'm going to multiply the bottom by a -4, which is going to give me a -1 Q there. So let's distribute. I am going to rewrite this, and I'm going to stay in green just because I want to. So D plus Q equals 32. And then the bottom one is going to be 4 times 0.10. That's minus 0.4. I'll just leave the 0 off for now. Plus minus 4 times 0.25. That's 1Q. But it's negative, isn't it? So let's change that. Negative Q. There we go. Now I can eliminate that. And then the last bit, I need to multiply minus 4 times 5.75, which means I have to open up my calculator again. And let's see. Minus 4 times 5.75 equals -23. Okay, so now I can combine. D minus a 0.4D is 0.6D. And then this zeroes out, so that equals 32 minus 23. That is, what is that, 9? So let's divide by 0.6, divide by 0.6. D equals 9 divided by 0.6 is 15. So there are 15 dimes. 15 dimes. And since there are 15 dimes, I just subtract 15 dimes from the 32 total coins, and that gives me, dimes plus quarters equals 32. So subtract 15, subtract 15. That goes away. The quarters equals, was that 17? Yeah. 17 quarters and 15 dimes. So DQ, hey, this here's DQ country, is 15, 17. How many quarters does she have? 17. All right. Got a couple more pages left, so I will see you on the next one. So